Welcome everyone to our video on molar enthalpies. In this video, we are going to define what molar enthalpy is, describe a bit how molar enthalpies and why they're used. Then we're going to compare heats or enthalpy of reactions to molar enthalpies. Molar enthalpy is simply the enthalpy change associated when 1 mole of a certain substance undergoes a physical or chemical change. We've already talked and learned about what enthalpy is and how it relates to chemical reactions. Well, molar enthalpy is a subset of enthalpies where we're just standardizing it to the amount of energy when 1 mole of the substance undergoes the change. We distinguish molar enthalpies from a regular enthalpy of reaction by using a subscript after the delta H. In general, we just use an X. However, when we have specific types of molar enthalpies, we use either a letter or an abbreviation. So for example, delta H with a subscript C is the molar enthalpy of combustion. The SI units for molar enthalpy are joules per mole, just as the SI units for enthalpy are joules. However, since most of the time we're going to be talking about chemical reactions, we'll often use kilojoules per mole because that's the scale at which energy exchanges in most chemical changes. Here is a brief table of some examples of some molar enthalpies taken from our textbook. So for example, the molar enthalpy of solution refers to the change when we are dissolving a solute into water. So the reference substance in the molar enthalpy of solution is 1 mole of the solute. Molar enthalpies of combustion, the reaction of a fuel, which is the reference substance. That's 1 mole of the fuel with oxygen to produce carbon dioxide and water. We've talked about the molar enthalpies of vaporization and fusion already. We can have molar enthalpies or heats of neutralization as well, the energy change associated with an acid-base neutralization reaction. And for those reactions, we can reference either the acid, so in this first example, in red, we have sulfuric acid, and it's referenced 1 mole of the acid. And in the second example, we've balanced it in a different way so that we end up with 1 mole of the base. So this would be per mole of the base. The enthalpy of reaction, or as we commonly refer to it, the heat of reaction, is dependent on the amount of substance reacting. So for example, if we have 1 gram of potassium chlorate dissolving in a liter of water, its delta H, or heat of reaction, will be positive 0.19 kilojoules. It absorbs that amount of heat when that amount of the solute dissolves. If we take 25 grams of potassium chlorate, the heat of reaction is 4.75 kilojoules. So these are just different heats of reaction, and those energy values change based upon the amounts that we're reacting. The molar enthalpy is talking about the same reaction, dissolving KClO3 in water, but it's referenced per mole of the solute, KClO3. So if we are to dissolve 1 mole of potassium chloride in water, it would absorb 42 kilojoules. Now, this isn't, I guess, technically always correct, but the way I like to think about the difference between heats of reaction and molar enthalpies is that often in problems, heats of reactions are the experimental values. They're the amounts of substances that we are actually working with, that you're experimenting with. A molar enthalpy are the reference values that are all standardized for a certain amount of a substance. One of the values of molar enthalpies is that they're readily available in reference manuals and in textbooks. And what this will allow us to do is to calculate heats of reaction without actually having to measure that in the lab. If we know the amount of energy that is exchanged when 1 mole of the substance react, we can use that value and calculate the amount of energy which is exchanged when any amount of that substance reacts. So it's a handy reference value for calculating heat exchanges. And in the following video, we'll go through some examples of calculating heat exchanges using molar enthalpies.